Thank you for watching the WEC-Sim Advanced Features Training course. My name is Kelly Rule from Sandia National Laboratories. This section of the training course will be focused on using WEC-Sim to model desalination. Wave-powered desalination plants can be modeled in WEC-Sim similar to power takeoff systems. In this instance of the desalination example in WEC-Sim, we model a reverse osmosis RO membrane, and it's modeled similar to power takeoff systems in WEC-Sim by providing forces back to the WEC. You can see this is done by the translational PTO actuation force block in the upper right-hand figure, coupled with the piston and RO subsystem in teal. For more information about the RO system that's modeled in this WEC-Sim application case, please refer to U 2018's journal publication. The citation is provided here on this slide. And the image shows a rendering of the general system where you have a oscillating wave energy converter that is pumping fluid into a hydraulic accumulator, which then passes through an RO membrane and generates permeate, and also feeds through a pressure exchanger. The model takes wave resource as its input, as shown in the lower left-hand slide, runs the wave energy farm or device, and then provides volumetric flow of permeate or desalinated water as its output. Again, this example is provided open access on the WEC-Sim's applications repository using the link below. Within the piston and RO block, there are a series of subsystem models that comprise the wave-powered desalination system. This represents numerically the configuration that was shown on the previous slide, where the RO system and piston consist of blocks that include pressure exchanger, hydraulic cylinder and directional valves, and an RO membrane. The RO membrane block takes in flow from the pressure accumulator, runs it through an RO membrane, and then generates both permeate and brine as its output. The pressure exchanger block takes in brine from the RO membrane and salt water from the ocean, and then pressurizes the working fluid and passes it back into the system. Altogether, each of these subsystems are what comprise the wave-powered desalination plant system model in WEC-Sim. While the desalination case provided in the WEC-Sim application repository is for a single wave energy converter running a desalination plant, this model can be expanded to include multiple wave energy converters and run for longer durations. The example shown on this slide is for a WEC-Sim run that includes 5 wave energy converters that were run for a 24-hour simulation. What you see on the left-hand side, the lower left, is the wave resource on an hourly basis that was used as the input to the 5 WEC farm. The Simulink model is shown at the top. And on the right-hand side, the desalinated water or permeate that's produced as the result of that 24-hour simulation. Information like this, the permeate that's produced from WEC-Sim, can then be used as an input to regional water network models to understand how desalination plants can affect local communities. This slide shows the WEC-Sim input file used to run the 5 WEC case with the wave-powered desalination plant model. As you can see, the single WEC case can be expanded to model 5 wave energy converters, but users must be careful when doing so because these input files can get cumbersome. I've just highlighted a few elements of this input file here. For example, the 24-hour case was run using WEC-Sim MCR, and a .map file was used to specify the MCR cases. Additionally, each of the 5 wave energy converters needed to be initialized for a total of 10 body blocks. For the OSWEC, that's both a flap and a base. And similarly, each of the wave energy converters have PTO blocks and constraint blocks that need to be initialized and defined. So care must be taken when developing these input files. And lastly, I just wanted to highlight that in this instance, the exact same RO system model was used. So while we did expand the single WEC case to 5 wave energy converters, we did not have to modify the RO system model in order to run this case. So it can be expanded, but care must be taken. Thank you very much for watching this WEC-Sim training course. For more information, please visit the WEC-Sim website and use our WEC-Sim issue board if you have any questions for our team. Thanks again. Bye.